All right, people, welcome once again to AGIT Codeworks, and today we are carrying on with our Oracle database masterclass. And then today we'll be looking at how to create and manage Oracle database tables using what we call DDL. Now, I also have to mention that we are going to be diving into Oracle database tables in depth. That's if you work as a DBA or you are a database administrator, or you actually handle database modeling for a complex application. Oracle is really the go-to database for doing this. So we are going to explore how Oracle objects are handled, how Oracle database are created, and then we are going to be looking at constraints and a whole lot about Oracle databases tables. All right, let's get this. Okay, so first of all, we said here create and manage Oracle tables using DDL, right? So first of all, what is a DDL, data definition language? DDL means data definition language, okay? Most times, if you're a database administrator or you model a database for an organization, DDL statements are basically what you use for defining data structures. Okay, defining data structures, altering data structures, and so on and so forth. That would be very different from what we call DML, which basically means manipulating data stored in a database. But this is actually where the designing of the database comes in. Okay, all right. Also, just to mention this, the main difference, one of the major differences between storing data in a relational database like Oracle, in a world-class relational database like Oracle, enterprise solutions like Oracle, as opposed to storing it in spreadsheets, is number one. An Oracle table is basically a smart table. What do I mean by a smart table? You could basically store that in it and create rules at the table level using constraints. Now, what this basically does is to enforce a rule across the lifetime of that table. Okay, so we'll be talking about all this and a lot more, and we'll be heading into the practical session after I've gone through a couple of slides. All right, let's look at the objectives for the training first of all. So first of all, we're going to be looking at some database objects. Now, a lot of people are used to tables as database objects, but basically Oracle has a lot of other database objects. We'll be looking at the major ones, which basically help in structuring data, handling data, and automating data management rules. Okay. Then we are going to be talking about to create these tables using a create table statement. We are going to create simple tables and then create more tables that are a bit more complex, the ones we have with constraints. And then we are going to be diving into what constraints are. When we start talking about constraints, we are going to be looking at the primary key and the foreign key constraints, the check constraint, the unique constraints, and a couple of other constraints, which help you enforce rules at the table level. I will explain what all that means in due time. Just stay with us. So now we are also going to be talking about how to create tables using a subquery. Right, this is actually an easier way to create a table based on another table model that already exists in the database. Okay, this can be in handy when you want to create a new table but has a table that's close to it in structure. You could just write a subquery which uses the other table as a base table to create base table, a template table, to now create the next table. All right. We are also going to be talking about how to alter tables, the alter table statement. This is usually useful when after you've already created a table and then later on you want to add a new column, rename a column, or drop an existing column. For example, I could have a table, let's say my staff table, and this is all my staff, their last names, their first names, their salary column, and then their hire date. And tomorrow I say, oh, I want to drop this last column here, which is the hire date column. Alter statement could do that. Or I want to add a new column over here. I can also alter a table to do that, or change some attributes on any column that is already existing. The alter table statement will do that for us. All right. So let's talk about the database objects, okay, before we go straight into creating tables. So basically we have 5 main Oracle database objects. They are not the only ones, but these are the main ones most DBAs would work with. First Oracle database object is a table. Now this is a no-brainer. It's a basic unit of storage composed of rows. So this is basically how our database stores its records. Okay, it's composed of rows and then columns. Okay, we've been talking about it up till now, and that's actually what we're going to be centering this particular tutorial on. In subsequent tutorial, we're still going to look at views. Okay, now what's a view? This is the second database object we have here. It logically represents subset of data from one or more tables. I will explain this in a bit. Now, basically, what this means is that now let's not forget, if we are given a database table, a holistic view, an Oracle database table could have millions of rows and in some cases hundreds of columns, depending on the size of the database. Okay, so now you might want to create independent existence. Let's just call this my table, okay, with a lot of rows and columns. I might want to create independent existence for a particular set of data. For example, let's say in a bank's database, of course, let's say we have MasterCard details, card records, transactions, users, their details, their email addresses, house addresses, and so on and so forth, all those records. And then let's say we hire Mr. A new staff, right? Let's just call this Mr. A. Mr. A was hired, and then we do not want Mr. A to have complete access to the entire organizational data. Okay, we can create subset of data. Of course, from the word subset, you will know that subset means a little fragment of a larger set. So I could say, okay, Mr. A, you are going to just be managing the ICT records. That means the records of those in the IT department, for example. So I could just create another table, which is not really another table. It's called a view, which is just a breakout from this already existing table. We are still going to look at all this practically, so just hold your horses. When we write the commands and create these tables, it's going to be super clear. Okay, and that's why it's important to hit the subscribe button, okay, and then the notification bell, so that when I update these tutorials and add the videos for looking at this, the other Oracle objects or any other updated content, you will get the notification, okay, and you will stay abreast with the next set of videos. All right, where were we? Okay, so this is a subset of data from this larger table, so that this would exist as an independent table, but it's still the same records in this larger table. Why would we do that? Number one is that this would make the data of the ICT department exist independent of the larger database set. But guess what? Any change that occurs here in these records, let's say he modifies the salary of someone in the IT department, is still modified on the base table. Or someone in the base table modifies or adds a new ICT staff, it's still modified here. So it gives us data independence. It makes data a lot more secure, so that because this Mr. A, who we just hired, has to have access to ICT department records, he does not have to start seeing the entire database. For example, access MasterCard transactions and high profile accounts and the data of every other person in every other department. That's what views are in a nutshell. We'll still look at that and we'll still create them. All right, so next thing we're going to talk about is what we call a sequence. Okay, a sequence. Now, sequence generates numeric values automatically. We have to add that here, automatically. It helps the database administrator generate numeric values. Now, I'll give an example. There are a lot of cases where a database needs to generate data uniquely, number one, or using a particular sequence. I'll give you an example. Let's say you are developing a database for a car company, and then, or let's say for a system that should hold a record of all the cars in your city, okay? And then you know that each car must have a unique identifier. Now, to maintain uniqueness across the entire table, you might want to generate the number for the ID of the cars uniquely, and then using a particular sequence. Instead of doing this manually, which is prone to errors, you can basically create a sequence, okay, and attach it to the table. So sequences are objects on their own, okay? If you create a sequence and you add it to the table, Each time an insert happens on the table using the sequence generates that number. Okay, a typical example would be, let's say, your school's database. Okay, a school's database, because everyone needs to have a unique registration number generated as a using a pattern or a sequence. Sequences are objects that can be used to achieve that. Take note of that. We will still be looking at the practicals. Okay, right, next we look at indexes. So indexes are nothing else but a way to improve the performance of SQL queries. Okay, it's basically for improving queries. Sometimes indexes are created automatically. They can also be created manually. So basically this is actually about performance, speeding up how data is accessed. If I had a table that has, let's say, 1 million records, okay, and I want to identify just 2 records out of that 1 million, basically the table will go through a full table scan. Full table scan would mean that Oracle SQL would go to the entire table. Okay, but with an index will serve as a pointer, which helps my queries go straight to the exact record it is looking for and retrieve it without much hassle. So indexes help improve performance of queries. We'll look at how that works. Just for the record, let me just say this ahead of time. Whenever you make any column primary key, once you create a primary key in a column, we'll be explaining what primary keys are later on in the tutorial. Once you make a column a primary key, indexes are created on them automatically. All right, so next thing we have here is a synonym. So what's a synonym? Synonym gives alternative names to an Oracle object. So basically, if the name of my table is really long and I want to access it with a shorter name to keep my query a lot easier and a lot simpler, I could create a synonym for that. More like the English meaning of the word synonym, an alternative name for an object. So it's used for giving alternative names to database objects, not just tables. Any other database object could have an alternative name using synonyms. All right, let's move on. All right, before we go into creating the tables and then start talking about constraints and all that, we are going to look at the naming rules. How do you name a table? Number one, a table name must begin with a letter. So I cannot begin my table name with a number, right? Or an asterisk. Please take note of that. The length has to be 1 to 30 characters long. Okay, now unless Oracle changes this in future versions, the name of an Oracle table can only contain 1 to 30 characters. I think 30 characters is really good enough to name a table, unless you want your table name to look like a textbook. On a lighter note though, so it has to contain A to Z in capital letter, or A to Z in small letters, or 0 to 9, an underscore, a $sign, and a hash. These are the characters it can contain. Okay, so notice asterisk is not here. So I cannot create an Oracle table and then make the name contain an asterisk. All right, it cannot duplicate the name of another object owned by the same user. For example, in our schema or our sample data, the name of the user is HR. So if this user HR already has one table named, let's say, staff, the same user HR cannot create another table named staff. All right, but a different user can actually have a table named staff. Okay, that just means that the user HR staff table will be called HR.staff, while the user, the other user, let's say user A table that is still staff, will be called user A.staff. That's called prefixing of table names. We'll talk about all that. Lastly, a table must not be an Oracle server reserved word. So that means that a table cannot, the name of a table cannot be, for example, create. Create is a statement in Oracle, like the where clause. Any reserved word used in SQL code cannot be the name of a table. Otherwise, you would basically confuse the Oracle database when you execute these statements, because it will try to interpret those words using their programmatic meanings. Okay, so you can name an Oracle database table things like where, create, alter, and so on and so forth, because these are Oracle database reserved keywords. All right, lastly, let's just talk about constraints. Or before we dive into constraints, let's go into our Oracle server now and see how we can create tables. All right, now, so let's dive in and create some simple tables before we go ahead and talk about constraints and alter and so on and so forth. Okay, so what I have here is my a software called Navicat connected to my Oracle database server. You could use any other middle party software for this, maybe SQL developer. If you have not yet set up a simple Oracle server for this practical, I have a link in the description for how to set up your Oracle server so we can have the exact same environment and also unlock your HRO schema. All right, let's create a simple table. So currently I have these objects. This is the HRO schema. That means all the objects owned by the HRO user. I have these already right here. Okay, so I wanted to create an extra table, but this is going to be a simple table without constraints. After I've created the table and we've seen how it works, then we'll dive in and talk about constraints too. All right, so let's start this. So let me create a table and we're going to call it let's say staff, for example. So I can say create table staff, right? Next is I'm going to list out the columns I want in staff. So my first column is going to be staff underscore ID. It's not going to have any constraint, like I said. Let's just keep this first table simple. We'll just use it to see how the creation works. Then we're going to create a proper table with constraints. So next thing I have to specify is the data type of the table. Data type means the type of data it will hold. Will it hold number data, character data, date data, and so on and so forth. You can always reference your Oracle documentation to see all the various data types that can be used. So we are saying it will be a number data with size, with a size of, let's just give this size of 10. That means 10 digits will be the max 10. This will be the size, right? So the data stored there will basically have a maximum of 10 digits. All right. So now what we're going to be doing is you put a comma, specify the next. So we have staff name, or you might want to have their first name. So first name will be var_2. That's Oracle data type for holding variable character strings. Okay, the length of the first name would be, let's say, maximum of 30 characters would be in your name, right? Then we have a surname column. Surname would be var_. That is also okay. Then let's say we have an email column. Okay, email column would also be var_, right? Let's make it 50 characters. Then we can have, let's say, the date on which the staff was hired. So let's just call it date underscore hired. All right, this will be of date data type. Now you can specify a default value for your date data. So you can say the default keyword, right? Sysdate. What this would simply mean is that each time I add a record to this table, the date hired becomes whatever the current date when I'm adding the record. Okay, instead of me manually looking for the date, you basically just enter the date the staff was hired using the default keyword sysdate. All right. So we can also now have the department they belong to. So that would be the department underscore ID. This is supposed to be a foreign key, but we'll still get to that point where we'll talk about constraints. So let's just make it a simple number, all right, with size of 5. All right, this is a simple table, does not have a constraint. Does not have a constraint. What that basically means that this table is not going to be smart. It's just going to be records of data. I could put whatever I want in it. I could just put a number here and characters here. I could put duplicates. I could even attempt to enter any kind of, let's say, salary. I don't have the salary column here, so we can add it just right here. I can add it just after surname. Of course, the order wouldn't matter. Salary. Okay, salary will be number. Number data type can have precision and scale, meaning decimal places. I can have 12 digits here and then it takes 2 decimal places. Well, this is usually useful because this is financial data. Okay, so now I could basically, let's say we have a rule in our organization that nobody should earn less than $500. This is not being enforced here, so basically I can add any salary for any staff and that would be okay. But enforcing that rule is where constraints come in, and we'll still deal with constraints right in this particular tutorial. But let's first of all create this simple table. All right, so we run this and then we get an okay. So it's okay, and that's what we want to see. So let's now run and view the structure of this table. So I could just say select with an asterisk from staff. That would simply mean I'm viewing the entire staff table. Okay, sorry, I ran this query now instead of this. Okay, that's why I got this name is already in use. So once you get this name is already in use, it means, and like I said, do you remember our database rules? One of them was that the same table, two tables cannot have the same name, owned by the same person. This is HR. Okay, so that's why it did not create again. It said name is already in use by an existing object. Okay, so but I want to run just this one here, right? So I can just highlight and run selected, or just drop down and say run current statement. So here we have the table data. It's basically still empty. Okay, we're going to, let's say we want to insert our first record into it. That this is a DML. We can just say insert into staff, where we have the staff underscore ID column, the first name column, the surname column, salary column, email column, and then our date underscore hired column, right? Then the department underscore ID column. Okay, this would be the columns I want to populate. Now, because date hired has a default value, you can still add your date manually, but since there's a default value, you can actually omit it and the default value will be inserted automatically. All right, so we have values here. Values would be, let me give a space. All right, so values would be, let's say my first staff number column, so 1. First name, let's just call the name John, right? Surname would be, let's just say John Anderson, right? Then salary could be $5,000.45 or whatever currency. All right, so email would be quoted. Remember, varchar or string data is usually quoted. Take note of that. Number data is not quoted. So we have let's say John Anderson at agit.com. Okay, department ID, that means the department number of the person. Let's say it's in department 2. We can add department 2 here. Let's see how this goes. Let's run this. So we do this and then we say run current statement. It said affected row, 1 row has been added. Let's run the select statement again, and then we notice a row has been added. So this is a simple table. Now there's a problem with this table, okay, because it doesn't have constraints. I'm trying to do a build up to why constraints are useful in a table. It's basically like a spreadsheet data in Excel or something. It's not yet smart. What I mean is no two people should have the same staff ID or the same email address. But if I add a second staff here and I make this staff ID still 1, right? And then the email still the same thing, and then changing just the name of the staff. Let's just say Ralph. All right, and I enter this record. And also please take note how the hire date just defaults to the current date. So I run this statement, run current statement. Notice it's still okay, the record goes through, but this does not enforce what we call data integrity, because staff ID is supposed to identify everybody uniquely, and like literally in the real world, two people cannot have the same email. But because this is just like a regular spreadsheet, it just takes the record. Now that makes us understand why constraints are important. Constraints help us enforce rules at the table level, okay, making our tables a lot smarter, so that over the lifetime of the table, whether it has 10 billion rows or not, it makes sure certain rules are followed. This is very useful for what we call data integrity. Now, Another example of why we need data integrity is, let's say we don't even have a department 2. There will be no way for us to know. Okay, so we are going to use the foreign key and primary key constraint to enforce this rule where only departments that exist can be added here. Two people cannot have the same emails. Staff ID cannot be empty, and then must be unique across the entire database, making it easy to have a way to search and get just one person's record and a way to identify a person uniquely. So let's talk about constraints now. All right, so talking about constraints, let's look at how to include constraints in an Oracle database table. Now I'm going to recreate our staff table just to demonstrate constraints. We're going to drop the table and recreate it. Drop is still one of our DDL statements. How to remove a table from a database called a drop statement. So we're going to drop it and then include constraints. So let's talk about constraints. So what are constraints? So I've mentioned it already in this same tutorial. Constraints enforce rules at the table level. Okay, so that rule of uniqueness, rule of or run a check each time a data is entered. And I want to say, okay, this particular column called gender must contain only that gender, or must contain, or I say our salaries cannot be anything higher than $1 million per month, something like that. So depending on the rules the company has, a DBA can integrate those rules programmatically into their data tables. All right, so constraints prevent the deletion of a table if there are dependencies. This is a very important one. If this table, let's say this is our staff table, right? Let's just call it staff. Bear with me, I'm writing with a mouse, not so convenient. So this is our staff table, and then we have a second table here. We'll call it our department table, right? Not bad. This is our department table, and then this staff table is dependent on the department table in the sense that our department records are kept here, and that is how it knows which departments are valuable. Okay, so this staff belong to departments. If I try to delete this department table, right, when there are staffs that still belong to that department, I will get an error message, even if the SQL statement doing the deletion is correct. Why? It's preventing deletion of data with tables depending on that data. So constraints prevent deletion of a table if there are dependencies. Example, staff belong to departments, so you cannot drop the departments table when there are active staffs in it. Okay, active member of staff in it. Okay, example, if it's an online store, this could be a product table, then a category table. Like these are our products, then this is a category table where we have is it an electronic device, is it a kitchen utensil, and so on and so forth. That would mean that products will belong to categories. So you would not be able to drop the categories table unless there is no more product depending on it. Okay, all right, so we will be enforcing these rules and these constraints very soon. So the following constraint types are valid. So these are the type of constraints we have in an Oracle database. Number one is our not null constraint. Okay, now what does the not null constraint do? The not null constraint basically enforces that a particular column cannot be empty. Let's say we have a rule that every staff must have a surname. You cannot leave it empty, but maybe we can allow you to leave your first name empty, but the surname column must not be empty. To avoid people from leaving it empty while adding records to our database, we can enforce a not null constraint. Then unique constraint. This is usually popular with email columns, where we understand that literally no two people in the entire planet can have the same email address. Okay, so a unique constraint can be used to enforce that at the table level, so that even if you try to add a new record with the same email for two members of staff, okay, you would have an error message. So it's enforcing uniqueness. Then the primary key constraint and then the foreign key constraint, they basically work together. Now the primary key constraint, remember I mentioned something about the staff ID being the column that identifies every single row uniquely. Okay, for cars that would be something like a license plate number. For students, that would be like a registration number. For banking transactions, that would be like a transaction ID. Okay, something that just identifies every row in a table uniquely. We are going to be looking how to add a primary key and then also add a foreign key. So what primary keys and foreign keys do is, okay, basically, let me give you a definition. I've told you already that the primary key is a column that identifies every row uniquely in a table or an entity. Tables can also be called entity in ER design. So a foreign key is a column in another table that a primary key in another table is dependent on. Okay, we'll explain all that. Then lastly, we have a check constraint. Now, what does the check constraint help us achieve? The check constraint basically helps us add arbitrary rules a particular column must follow. We can use this to enforce, let's say, salary grading, salary checking. That means I might have a rule that you can't leave salary at zero. Someone's salary cannot be zero or must be greater than $100 or something. So we can put a check so that even when that data wants to be added to our database table, it will be rejected by the Oracle database. All right. Before we go ahead to do the practical, let's look at guidelines for creating these constraints. Okay, guidelines for creating constraints. Number one is that you can give your constraint, you can name a constraint, or the Oracle server will generate a name for you using this format. We'll look at how this works. When we start adding constraints, we'll look at the both methods for adding constraints. So we can also create a constraint. Either you create a constraint at the same time when you are creating the table, or after the creation of the table, you can add the constraint later. Most cases, people prefer adding the constraints before the lifetime of the table starts, so that the table is created along with the rules. So we're going to define the constraint at the column or table level. Okay, we are going to talk about this. It's going to be in the practical. We are going to view a constraint in a data dictionary. This word is popping up for the first time, something we call the data dictionary. So data dictionary is basically a table not created by a user. It's a system table. But what it does is to hold, just like the English dictionary, holds every single recorded word in English, so to speak. So data dictionary holds record of all the objects created in your Oracle database server. What does that mean? You can use data dictionary to view which constraint has been created, which constraints belong to a particular user. Now, some data dictionary objects a user can access, some a user cannot access, depending on the access level. Data dictionary is a topic for another day, but we're going to just use them to view which constraint exists in the system. Okay, so now let's pop back to our Navicat or SQL developer, and let's create constraints for our table. All right, so first of all, I'm going to drop this table. If you notice, I think I added a staff table. Let me refresh this. So if I refresh, you notice I have staff tables. I want to drop it. It does not have any constraints on it. I could add records however I wanted without any restrictions. So let's drop the table. So drop table staff. Okay. You can also say, just for the records, you can also say hr.staff. This is saying drop staff table in the HR schema. That would mean drop staff table stored in the HR users schema. All right. So now, but this becomes useful when it's not the HR user working. But since it's the HR user, when you just say staff without the HR prefix, it basically says, okay, it's the staff table in this my current schema. So let's run this. This is not so useful now because we're already connected as HR. So I run the current statement, and then it says, okay, that means the table is gone. If I refresh here, you notice the staff table is no longer part of my database. All right, so let's recreate this staff table now. So we already have the create table statement here, so I'll just reuse it. So basically, the way you create constraints is basically after defining the name of the column, the data type, what follows here is the constraint. Okay, so the first and simplest way to do this is, so let me make staff ID the primary key column. So I will say primary key here, right? So this makes staff ID my primary key. Now first name will not have any constraint on it. Let me make surname a not null column, so I can specify not null. So this becomes a column that cannot be empty. Now let me put a check in our salary saying that no staff should earn less than $1,000 or whatever your currency is. So you would say check. So that's the check constraint with a column here. So check and verify salary must be greater than 1,000. Okay. Email must be unique. So you put the unique keyword. Okay. Hire date is okay. Department ID is supposed to be a foreign key referencing another table. So I'll just leave that, the foreign key part, as a discussion for later in this tutorial. Let's watch how these other constraints work now. Okay, so let me run this. I could just select it and say run selected. And here I have it. Okay, same table has been created again, but this time around it's a lot smarter. It contains constraints. Now let's see how that works. Now let's try to add our first record. That would be this. Ralph, blah 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 blah. This should go through. Okay, this should go through. We are not breaking any rule. Okay, this would go through. So I just highlight and I run selected, and it says okay. So let's view the content of our staff table. So you see, number one, that's an ID for the first user. His name is Ralph. Username is salary. His email. Perfect. So let's say I add a second user now. Right, number two, his name Simon Fisk, salary still this, but the email remains the same with the previous email in the system. Without any manual intervention, this database is smart enough to pick this. Why? Because there is a unique constraint on the email field or the email column. So let's not take my word for it, and let's see if the constraint works. So here I run selected. Oh, an error message. What does it say? Unique constraint violated. So it says, hey, I'm supposed to maintain some kind of integrity. These were rules I got when I was created as a table. So throughout my lifetime, I have to make sure no two people have the same email. That's a good way to maintain data integrity. So the table remains unchanged because a constraint was violated in the insert statement, so it cannot go through. This is also true when you are running update statements and so on and so forth. You can't, even if the user is already existing, you won't be able to update an email to an already existing email. I think that's very popular because most of the forms we fill out online or create accounts, they tell you duplicate emails cannot be used. Most of the time, it's rules that are already existing in the base, in the database at the back end of whatever application you are using. Okay, I hope we get that. So let's now change this and let's not violate the rule. So let's, and by the way, most times this rule violation could be advertent or inadvertent. It could be an error as well. So you, of course, you would like the table to pick that, even when the developer or the database administrator wants to insert these records mistakenly. The table would already on its own help us mitigate that problem. So I will just say Simon Fisk at, let's use Gmail this time.com. All right, it's in department 2. Is staff ID, sorry, is true also. So let's run this. We select good. No constraint was being violated, so the data went in. So we can check run selected, and then we have a second record here. Now this is also true for the check constraint. Let's say I'm adding a third record, and then we try to violate someone earning less than 1,000, which was a rule we specified here. Okay, the check constraint for the salary column. So I come here and basically I broke company policy and I want to pay a staff less. Let's say $700 now. Now that's a constraint violation, as I've already explained. So let's see how that goes now. Okay, this is staff tray. Instead of Simon Fisk, let's just say Luis Figo. All right, so this would be Luis F at agitcodeworks.com, and then department could be 4. All right, we are violating the salary constraint, but the rest of the data seems okay. So we run this. Oh, an error here. It says check constraint being violated. Exactly. So we get the point. So that also goes for every other constraint. Like if I decide to leave surname as null, right? If surname is null, that is empty, and I don't, and I say 15, yes, I'm not violating this rule. So the null constraint would also be flagged. Cannot insert a null because the table owner said, hey, if your record must be here, surname must be filled out. You could choose to leave first name empty, but surname must be filled out. All right, so that's how to add these constraints we mentioned. Now let's go into the foreign key and the primary key constraint. Let's look at how this works. All right, so what I'll do now is I'm about to create some what I call dependencies. Okay, about what I call dependencies. What does that mean? Let me first of all explain the foreign key and primary key relationship. Okay, so it's called entity relationship model. I'm doing this now to introduce the foreign key properly. All right, first of all, let me use our existing employee records to give you an example of a relationship like that. So let's just select asterisk from our employees table. I'm sure we all have employees table. If your setup is exactly done like mine, if it's not, please, there'll be a link in the description where you can go and set up your Oracle server environment according to the concept we are using in this tutorial. All right, so I can run current statement here. So this is a table we call the employees table, right? Okay, so now as a reference point to explain entity relationship model or foreign key and primary key relationships, okay, this is a column called department ID. So notice we have department 90, department 60, department 100, and so on and so forth. Now these are not just numbers the developer added here and in an assumption that we have these departments. So basically there's a table controlling which departments can be added here. Let's look at that table. We can just say select asterisk. Let me copy and just paste this here. So we just select the departments table this time around. All right, if we run this, you see under table called department. So notice that department 10 is administration, department 20 is marketing, department 30 is purchasing, and so on and so forth. So what I'm basically saying here is that these departments here are the only valid departments that can be added in the employees table. Okay, so that means there is a foreign key primary key relationship between the departments table and the employees table. Okay, so if I try to insert, let's say, department 10000, because there's no department 100 here in departments table, an error message will be encountered. Okay, so all right, let's drop our employees table again and then create a table it will depend on. All right, so let's say we are going to create another table called dept, DEPT. Okay, so we can say, so let me drop my employees table first. So drop table employees. Oh, okay, now watch this. It's an error. I was supposed to drop the staff table. I tried to drop the employees table. Now what's going on here? Unique primary key table referenced by foreign key. So this is a table that has dependencies. That is why it could not be dropped. So that was exactly what I was explaining. Now that was a mistake, but notice how constraints kept me from dropping that table. So here we have the staff table. Let's drop it properly now. Okay, run selected. All right, so it says okay here. That means our staff table has been dropped. All right, so let's create a table it will depend on now. So I would say create table. So let's call it my department. Of course, the name could be anything. All right, open my semicolon. All right, so we'll first of all have the department ID. Let's call this department underscore ID. It's going to be a number. The max number of digits would be 5. then of course this will be a primary key, right? Remember it, because it's going to be unique and it's going to be referenced by this department ID when we are recreating this table. Okay, so department ID, then actually name of the department, let's call it department underscore name. Okay, this would be of course like a string data, so we can just say varchar2 and then the size, let's say 40 characters max. You might also want any other data you want about your department, you can add it, okay, like the manager and all those things, but let's just have the ID and the name of our department. Cool. All right, so let's create this table now. Run. So it says okay. So right now we have a department table. So I called it my department, so there's a department table existing. So let's just add a couple of departments to it. So I could say insert into my department, right? You can specify the column first, so which is department underscore ID, comma, department underscore name. So the values, which would so we have department 1, let's just call it sales department. So if we run this, we have a sales department. Okay, we can add a second department, department 2, let's call department 2 the IT department. All right. Now normally in a real life environment you can also load records from another table. Okay, so basically in real life you might also want to load this record from an Excel sheet or something. We are going to do subsequent videos on ETL, extract, transform and load. We see how we can get data from CSV files, Excel sheets into Oracle database and export back to Excel and so on and so forth. But for now we're adding the records manually. Okay, so we can add a third department, which is let's just say executive, an executive department. We could also add a fourth one. We'll call that security. Then one last one. So we have 5 departments, HR. All right, let's view our departments table now. Select asterisks from departments. All right, so notice we have not department, this should be my department. All right, so run it. So we have this table containing 1 sales department, 2 the IT department, 3 the executive department, 4 security, and 5 our HR department. Okay, so now let's create our staff table and then create a primary key that would be dependent on this department ID here. All right, so we already have this in place. So to make this department ID column reference this department ID in another table, I would say references. So references my departments. So this simply means it references a table called my departments, which is also this one we created here, right? My departments. Now, which column does it reference in it? You open a parenthesis and then you say it references the department underscore ID column. All right. References my departments table. Okay, so this column will reference my departments table. Then which column in it does it reference? The department underscore ID column. All right, we run this now and let's see what we get. So it says okay here, created successfully. Now let's look at what this particular constraint gives us. That means I cannot add a department to this table if the department does not already exist on this my department table. right? Now let's put that in practice. So let's first of all add some staff records. So I would say we have to do this again, insert into staff. So I would have staff underscore ID, first name, surname, email, date underscore hired, and then the department underscore ID. Okay, this will be followed by our values keyword. Of course, the values is also arranged in the same order as the column listed. This time around, we left date hired here. That's still okay. So the first staff one, his first name, let's say, is John. Surname could be Simons. Then salary 6,000. Email could be John Simons at agit.com. Date hired, we just want to return today's date, so we can just say sys date. All right, we have a video on how to work with dates, so you can say sys date plus a couple of days to add a date in the future, or sys date minus 3 to add 3 days in the past. All right, so that's for hire date. So now the department ID, let's say this guy is a, remember this is the table is referencing, this guy is in the sales department. That would make his department ID 1. Okay, so here we go. So let's insert his record. We are not breaking any integrity constraints, so we can run this and it says okay. Let's add a second staff. This guy is going to be Gabriel. Surname. So email is gabi@agit.com. He's in the department 2. That should be the IT department. So if we run this guy is in the IT department. All right, so hence as specified here, department 2 is in the IT department. So if we view our staff table, this is what we get. So we have this guy in department sales. This is department 2. That will be department IT. Okay, so now what if we now try to add a department that does not exist in our regular table without constraints? That would have worked. Let's say department 6 or department 7. As you can see, it does not exist here. So to enforce integrity, the foreign key and primary key relationship is what does that, and this is where we created it, saying that this particular column references this table, all right, and it references this column in the table. All right, let's try and break that rule. Let's see how it goes. So I'm adding this guy to department 7. Of course, we know we don't have one of that. So even if we respect every other rule, for example, the primary key rule is respected here. This guy is let's call him Francis. His surname is Hanks. Email to is different. So let's call it email is fhanks@agit. Everything is good, but this department does not exist. There will be no way I could know manually, because the department, remember, could be created sometime in the future in the company or in the organization. But for right now, the ER entity relationship constraint would keep it from actually working. Exactly, it says integrity constraint violated, parent key not found. What does that mean? I've explained before, just for emphasis, that means there is no department ID 7 here. So basically, this is a database that will that would respect our integrity constraint all through its lifetime. These constraints and these rules are basically decided by the database model given to the developer or the administrator by the organization. Okay, so now that we've gotten that, let's move on to the next thing. We are going to be talking about the alter statement for our Oracle database tables. Let's go to the slides and explain this first. All right, so here we have something we call the alter table statement. What is this used for? Now, remember we've just, from our practical session, which I believe we've gone through it, we created a staff table and a department table. We talked about unique constraints, the check constraints. We talked about the primary key and foreign key constraint, and we explained how it enforces integrity, okay, across database objects. Now, where does the alter table come in? Now, you might have already created a table and you need to alter the structure. For example, you want to redefine a column, or let's say you want to change the size of a column, or you want to rename a column or add a new column. The alter statement will help us do that. Let's look at what we have on the slides. So we can use the alter table statement to add a new column. I believe we understand what that means. Modify an existing column definition. By definition, I mean the data type and the constraints defined in it can still be modified. Okay, but please understand that when you are modifying a table, it still enforces its constraints unless these constraints are disabled. Okay, define a default value for the new column. Okay, so we might want to define a default value for a column that already exists but doesn't have a default value, or even define a default value for a column I added newly. We can also drop a column. Example, you can say, okay, there was a date of birth column and now we don't want date of birth column, so you want to drop that. You can do that. Rename a column, like renaming the staff ID column to staff underscore ID underscore PK, or renaming the department underscore ID column to depth underscore ID, whatever renaming you want to do. And then also something important, change a table to read-only status. Now I'll tell you why this is very important. Number one is remember, our Oracle is a database system that can be deployed in a distributed environment. What I mean by distributed environment is that we could have a central database here, accessed from different geographical locations on the planet, literally, okay, or accessed by different offices, okay, in the same building. So that means data is being fed real time to these systems. For example, if this was a banking solution, for example, this could be a mobile app connecting to this record. This could be an ATM machine connecting to this record, and this could also be like a POS system connecting to this record. So these records have to, so let's say I want to do a maintenance on this table, and I want, within that period I'm running that maintenance, or maybe I want to modify some records, I want data from the table to only be readable but not modifiable, so that after my maintenance I can put the table back to read-write mode. This could be done using alter table statement to change the status of the table from read-write to read-only. In read-write mode, the table can be modified and also can be read, that means viewed. But in read-only status, you can only view records, so that means updates and insert statements would not work on that table. Anything that modifies the table will not work until, let's say I'm the DBA, when I'm done with the table maintenance, then I could put it back to read-write mode. So let's look at how the alter table statement works. All right, let's go back to our Navicat and let's get this. Okay, if I was adding a street address to my department table, let's say different departments exist in different locations across a city, right? For example. So here we might want to say alter table. So let me alter my table. Let's just move down here. So this is what the table looks like. I want to alter it and add a new column, street address. All right, so that would be alter table my departments, right? We're going to specify the add clause. That means we're adding a new column. So we'll call that street underscore. Okay, so we call that street underscore address, and we say add street address varchar. Let's say it could have 50 characters, depending. Okay. So if we run this, so it says okay. Now if we view our department table, right, we will notice there's a street address column. So that was added successfully. And it's also easy to now update and add a street address to these departments. So I could just say all right, we could say update. So we could say update my departments set street underscore address equals to number 4 Carlton Avenue. Okay, now where department underscore ID is equal to 1. That means department 1 has a street address now, number 4 Carlton Avenue. So we run this, run selected, and it's okay. Then when we select star from my department, you would observe number 4 Carlton Avenue, and so on and so forth. Now let's also talk about how to, let's say you want to add multiple columns. So if you wanted to add multiple column definitions, right, multiple new columns, it would be, and it will still look like this, but just that this time around, after the add column, you can open this parenthesis, then close it here, just like when you were creating the table, and then you can modify and add multiple columns. So I could be adding, okay, this can be street address. Let's call this city. That means the city where the location is in. We could also now say add a manager. Let's say manager underscore ID column. This will be a number. I mean the number of the manager. That will be 5. All right, so we're adding multiple columns now to the department table. So this is just like last time I added only one street address, right? So but this is just a way to add multiple. So I could keep saying comma and adding more columns, right? So this will be it. So let's alter and add this. Okay, it says okay here. So now let's view the department table once more. So we view it, and then here we have the city and manager ID have been added. So so that's basically it. So we could also modify an existing column. Okay, for example, we have the street address. We want to change the type. Let's say street address currently has, I think, 50 characters, but I want street address to have something like 100 characters. Okay, it would look like this. So this would become alter tables, my departments, modify. Take note of that. We say modify here. Which column are we modifying? The street underscore address column is being modified. The data type now I want to change it to varchar, but this time around it will be 100 characters, okay, or 150. So which is increasing how much the size of the column records it can hold. So this is modify, the name of the column you want to modify, and then the new data type. Okay, so we can alter again, and we see here that worked. So you can basically describe a table to see the type of data it holds and so on. So that's how to modify our table. Then lastly, we are going to look at, of course, I can also modify. Don't forget, you can modify and also add new constraints and so on and so forth. Like I might want it to be unique, so I might just say unique here, right? So I'm modifying the street address to have a unique constraint. So you see that. So that means that you don't even have to define some of these things at the table level. At table creation stage, you can actually modify your column and add a new constraint. So now street address becomes unique. You understand what unique does. I would not have to go through that all over again. Now let's say we want to drop some of these columns that we've added. That would be alter table by departments. We will say drop column. Okay, we can drop street underscore address. Okay, drop column column name street underscore address. When we run this, we get okay. So if we query our my department table now, you would notice street address is gone. So that's basically how you can alter a column in various ways. Drop the column, add new columns. Now what if you wanted to rename? Let's say I wanted manager underscore ID to be manager number. Okay, I wanted manager underscore ID to be manager number. So it would be alter table my departments, then you go rename, right? Rename column. Now I have to specify the first name of the column, the current name of the column. I mean, that would be manager underscore ID. What are we renaming it to? Rename column manager ID to, let's say, manager underscore number, so to speak. So we are altering the table in the data structure of the table. So we run this, it says okay, and that's what we want to see. And I run this here, then I notice manager ID has become manager number. That is for the alter table statement. Now I'm going to still do a follow-up class on this, a follow-up tutorial on this. We've seen how the Oracle database works. We've seen how to create the table object, the rules for creating the table objects. We've looked at the constraints, the unique constraint, not null constraint, foreign key and primary key constraints, and we've looked at how to alter the table. One more alter table statement we are going to talk about is how to put the table in read-only mode. Okay, the alter table, let us check out the staff table. You know, right now we can modify the staff table. We can view and modify it, right? But we want to make it that it can be viewed now and no longer modified. All right, let's get how to do this. So basically, I can just say alter table staff read only. That will be it. Alter table staff read only. If I run this, it says okay, staff is now read only. Let's verify that. Let's try to add a new record to staff. Let's say a fourth staff, right? Let me just modify this email so it doesn't have the same email, right? Every data stays as it is. So we try to insert a new record. Oh, we said update operation not allowed on this table. That's because it's in a read-only mode. I could also say alter table staff read write, and then run selection, run the selected code. Now, just like taking candy from a baby, easily it has been turned back to read write mode. So now I can actually modify and add a new staff. Okay, so I'll run this now. Okay, integrity constraint parent key. Okay, makes sense. This is a violation of our parent key constraint. Department ID. There's no department 7, of course. So we add into department 2, and that's it. Our code should work. So I hope you observe the way constraints help me obey certain rules at the table level, right? All right, so we've come to the end of this particular tutorial. This is all you need to know about Oracle data tables. We're going to be talking about the other database objects in subsequent tutorials, and for you to stay abreast with the next set of tutorials I will upload still on the topic, hit the like and the subscribe button if you found the video useful, and then I will see you in the next class, and do have a wonderful rest of the day.